So we've just discussed identifying significant digits or significant figures, and now we're going to be talking about utilizing them and what makes how you need to address them when you're doing an addition problem or a subtraction problem versus a multiplication or division problem. Okay, so for addition and subtraction, the rules are basically the same. The answer that you come up with is rounded to the fewest number of decimal places that are present in the added or subtracted values. So, as an example, if you had 10.003 plus, 1.1, well, what you're going to look for is you're looking for you come up with an answer that's 11.103, but this answer would not be correct. It seems like it would because, well, it's using all of the numbers. But your rules for significant figures are you're going to round to the fewest number of decimal places. Okay, so how many decimal places are here? 1. How many decimal places are here? 3. Your lowest number of decimal places is that 1. So what you need to do is round this number down to 11.1. Okay. Now multiplication and division, slightly different rules. The answer is rounded to the fewest number of significant figures. Okay. Now notice when we were doing addition and subtraction, we were talking about decimal places, whereas multiplication and division, we're looking at significant figures. So if you had something like 10 or 12.6 times 1.2, okay. Now both of these have, or actually let's go ahead and change it, 12.60 and 1.2. This one has 2 decimal places, this one has 1 decimal place, but we don't care about decimal places, we care about the number of significant figures. So what I'm going to write here is the number of significant figures. This top number, I have 4 significant figures, this bottom number, I have 2 significant figures. So what I need to do is I need to round my number, or round my answer, to reflect only 2 significant figures. Okay, now, and I can plug that into my calculator, which, oh man, I did what I always do with my calculator. I used it and put it somewhere and lost it. Oh, but lo and behold, I found it. 12.60 times 1.2 equals 15.12. Okay, we got to get to 2 sig figs. This answer might look a little bit weird, but it's going to be 1.5 times 10 to the, that would be first. Okay, so that would be your actual answer for this. This would be the best answer reflecting the rules for significant figure calculations with multiplication and division. Okay, so again, practice. Practice makes perfect, or practice at least reflects or results in improvement. Millie Mole put 25.6 milliliters of water into a graduated cylinder. Okay, she added a chunk of metal. The water level rose to 28.9 milliliters. What is the volume of this metal? Okay, so what we're seeing is substance. So to visualize that, I'm going to draw my grad cylinder. There's my grad cylinder. I've got water up to here, 25.6, and then I add a chunk. There we go. And the chunk of metal causes the volume to raise up to 28.9. Okay, so what I want to do is I want to say 28.9 minus 25.6. The reason that I'm subtracting those two is the difference between them is the difference in the, is the volume of my substance. So I'll say 28.9 minus 25.6. Okay, before we proceed, how many decimal places? 1 and 1. So our answer is going to have 1 decimal place. So my answer to this would be, well, 3.3. Okay. Did I care about the number of significant figures? No, I don't. So my answer, the volume of my metal, 3.3 milliliters. Okay. Now, I hope that makes sense for everyone. Part 2 here, Millie Mole, that's a person, dried off the metal and found that the dry metal had a mass of 13.467 grams. Calculate the density of the metal. D is equal to M over V. So D is equal to our mass divided by our volume. We figured out from our first part what our volume was, 3.3 milliliters. Now our mass is 13.467 grams. Okay. Now, when we're doing a division problem, what we care about is we care about the number of significant figures. So I'm going to rewrite this as 13.467 divided by 3.3. Okay, so I've got 5 sig figs versus 2 sig figs. So my answer is going to have only 2 significant figures. So I'll plug this in, and what I always like to do is I like to solve the problem and then round. So 13.467 divided by 3.3. And I get an answer that is 4.080909090, or no, 1. Okay. Now that answer, that's kind of well, that's a lot of numbers and that's got a lot of precision, but that's not exactly what I can work with. Instead, what I can work with is this number of 2 significant figures. So what I'm going to do is I'm going to say, well, I need to round this to only have 2 significant figures. And that rounds to 4.1. My units for density are grams per milliliter. All right, next up is, well, sig figs and multiple step calculations. What we just did was we had 2 separate calculations where we drew conclusions. Now what we're going to do is we're going to compile all of these. Now, I didn't include in your math review the order of operations, but order of operations do end up being potentially involved here. But what this says and what this directs us to do is to reduce rounding errors, we carry extra significant figures through multi-step calculations and only round at the very end. Use an underline to determine, use an underline to keep track of the last sig fig in each intermediate answer. Okay, so to see that, we've got this 144.77 minus, or 145.77 minus 144.98 divided by 5.6197. So the first thing that we want to do is we want to look at this as we've got this function right up at the top that's in parentheses. So if you remember from, heck, I don't know when this was learned, PEMDAS, your order of operations. Please excuse my dear Aunt Sally, I think is what I learned. My wife chuckled at that. So we've got parentheses we've got to do first. Exponents. Multiplication. I'm just going to write multiple. Okay, I'm going to write the whole word. Division, addition, and subtraction. Okay, so we've got this parenthetical function to solve for. I don't know if that's the right time to use that word. I feel like it is. I don't know if that's a word actually, but I feel like it is. So I'm going to do 145.77 minus 144.98. Plug that into the old calculator. That gives me an answer of 0.79. Okay, now that answer right there, is that a problem or is that right? Remember, when you're doing multiplication, or sorry, when you're doing addition or subtraction, you care about the number of decimal places. So, do I care that I now only have 2 sig figs? No, I don't. It's worth noting though, because, well, is that going to be important whenever I'm working with a division problem? It absolutely is. So what I have is my 2 numbers beyond the decimal point, and this gives me 2 sig figs. So I will now write out 0.79 divided by 5.6197. Okay, so 0.79 divided by 5.6197. That equals 0.140576899. Okay, now when you want to come up with the answer for this, and well, you want to come up with the right answer for this, you got to go back to, well, we have 2 sig figs, and now I'm just writing the number of sig figs related to one another. We've got 2 in the numerator, and then we have a total of 5 in the denominator. Now that 5 kind of doesn't matter. The 2 is what matters. So I'm going to take this number and I'm going to round it to 1.4 times 10 to the minus 1. So that is the correct answer for this problem. I hope this was helpful, and proceed onward. Have a good one.